Have you ever opened an NginX config file and just stared at it like you were trying to decipher some ancient cryptic text? Yeah, we've all been there. Well, today we are pulling back that curtain. We're going to transform that wall of text from a mystery into a clear, confident blueprint for building seriously high-performance web services. Let's get right into it. We're going to tackle this with a building block approach. We'll start at the very heart of NginX, its core engine, and then, one by one, we'll layer on its most powerful features, everything from proxying to security. By the time we're done, you'll see exactly how all these pieces snap together into one complete, cohesive picture. All right, first things first, we have to talk about the absolute foundation of NginX's legendary performance. To really get why it's so incredibly fast and efficient, we first need to understand how it's built from the ground up. And that really leads us to the million-dollar question, doesn't it? This isn't just some made-up number. How can a single, lightweight server process thousands, even tens of thousands, of connections at the same time, without even breaking a sweat? Especially when older web servers would just completely fall over under that kind of load? Well, the answer is this absolutely brilliant idea, the event-driven model. See, instead of dedicating an entire worker process to just sit there and wait for one single connection, NginX has one hyper-efficient worker that just listens for events. Think of it like a grandmaster playing thousands of chess games at once. They don't stare at one board waiting for a move. They only pay attention to the board where a move has just been made. That is the secret sauce. It's a non-blocking approach. And this really shows the difference in stark contrast. The traditional model, one thread for every connection, is like having a dedicated waiter for every single person in a huge restaurant. It's incredibly wasteful. NginX is totally different. You have a master process, kind of like the restaurant manager, who supervises a few highly skilled worker processes. Those are our waiters. Each waiter can handle dozens of tables, only acting when a table actually needs something. No one is just standing around. That efficiency is everything. So the most important thing to take away from this is that by not getting blocked waiting on slow clients or slow networks, NginX can handle a massive number of users all at once, using just a tiny fraction of the server's memory and CPU. This is the architectural magic that makes all the other cool stuff possible. Okay, now that we have that solid foundation, let's build on it with NginX's most famous job, being a reverse proxy. Just think of it as the smart, secure, and super efficient front door for all of your backend applications. So why would you even want this front door? Well, imagine it's like a receptionist in a big office building. It does load balancing, right? It directs visitors to different offices so no single one gets totally swamped. It provides security, keeping the internal layout of the building, your back-end servers, completely private. It handles all the complex stuff like encrypting and decrypting packages, that's SSL termination, so the apps themselves don't have to worry about it. And it can even keep copies of common documents handy, that's caching, to give them out way faster. And to make all this magic happen, you really only need a couple of key commands. Proxy pass is the simple one. It just says, hey, send this request over to that server. But proxy set header, that one is absolutely vital. It makes sure your backend application actually knows who the original visitor was by passing along critical info like their real IP address. Without this, your application is basically flying blind. So the takeaway here is simple, but it's really profound. Using NginX as a reverse proxy isn't just about moving traffic around. It's about adding this powerful layer of security, performance, and resilience right in front of your applications. Okay, this next topic gets a little more into the weeds, but trust me, it is absolutely critical for performance. Let's talk about request buffering, basically NginX's ability to be a shock absorber between your fast application and a potentially slow user. Here's how it works. Your application server, what we call the upstream server, generates its response and sends it to NginX. NginX grabs it super fast in one quick gulp and stores it in memory. This instantly frees up your application to go handle the next request. Then, NginX turns around and patiently streams that data down to the user at whatever speed their connection can handle. It's literally a shock absorber, protecting your fast backend from getting bogged down by slow clients. Now, this is the crucial trade-off you have to understand. With buffering on, and this is the default setting, your backend server is protected, but the user has to wait for NginX to get the entire response before they see even the first byte of data. With buffering off, the user gets data instantly, but now your precious, expensive application server is tied up, stuck in a slow conversation directly with that user's slow connection. So when would you ever want to turn it off? The answer is anytime you need real-time communication. We're talking live video streams, chat apps that use WebSockets, or anything where that immediate first byte response is more important than protecting the backend. For those specific use cases, you turn buffering off and just let the data flow right through. So the bottom line is really understanding this choice. The default setting protects your infrastructure, which is usually what you want. You only change it when the nature of your application absolutely demands that real-time synchronous connection. All right, let's shift gears and talk about something that is 100% non-negotiable on the modern web: security. Specifically, how we enable HTTPS using SSL and TLS certificates. Setting up the basics is surprisingly easy. First, you tell NginX to listen on port 443, the standard port for SSL traffic. Then you just point it to your public SSL certificate and your private SSL certificate key. And this part is critical. You have to specify the SSL protocols. It is absolutely essential that you only allow modern, secure protocols like TLS 1.2 and TLS 1.3. The older ones have known security holes that hackers can and will exploit. And really, that's the bottom line. A proper, secure SSL setup isn't a feature anymore. It's the price of entry to be on the web. Always use modern protocols, use strong cipher suites, and enforce HTTPS with headers like HTST. That's the one that tells browsers to only ever talk to your site over a secure connection. It's how you protect your users, period. Now for one of NginX's original superpowers, its ability to serve static files. Images, CSS, JavaScript, at absolutely mind-blowing speeds. And the secret to doing this is all about avoiding unnecessary work. So let's look at the old, inefficient way this used to work. To send a file, the system would first read it from the disk into the operating system's memory, the kernel space. Then it would copy that data again into the application's memory. Then, to send it out, the application would have to copy it all the way back to the kernel's network memory. That is so much pointless copying, just wasting CPU cycles and time. But NginX, with one simple directive, sendfile on, takes what I like to call the kernel's express lane. The operating system copies the file data directly from the disk buffer to the network buffer, completely bypassing the application layer. The data never has to be copied around needlessly. This is called zero copy, and it is phenomenally efficient. So please remember this, that one little line, sendfile on, unlocks a deep kernel-level optimization that turns NginX into an absolute beast for serving static content. It is one of the biggest and easiest performance wins you can possibly get. Okay, we've laid all the bricks. We understand the core engine, we get proxying, buffering, security, and efficient file serving. So now, let's put it all together and see what our final blueprint actually looks like in practice. And here it is, the complete blueprint. You can see how every piece we've talked about connects. Right up top, we're defining our efficient, event-driven worker model. Then our main server block is handling all the SSL termination with modern, secure protocols. And inside that, one location block is dedicated to serving our static files, using sendfile for maximum speed. And right next to it, another location block uses proxy pass to intelligently forward our API requests to the backend, with buffering on by default to keep it safe. Each piece has its place and its purpose. See? It's not a mystery anymore. It's a logical, powerful system. So the next time you open up an NginX config file, what's the very first optimization you're going to look for?